Assalamu alaikum students. Today is our new lecture and the lecture name is variation of parameters. So it is a kind of finding, it is a method kind of finding out the particular solution, but you know it's a versatile kind of method. Okay, in the previous videos in the previous lectures we have studied about how to find the particular solution by using two basic methods. We have studied first one is particular solution or method of undetermined coefficients, and the second one is by annihilator operators, and the third one is additional one, that is of special type if you have x functions multiplied instead of these scalar functions. So that is Cauchy-Euler equation, and we have studied its basic method and also its alternative method. But now if you have not these constant, those all methods, previous methods were restricted for the constant coefficients. Like if we have this equation a n y to the power n, that means nth derivative of y, plus a n minus 1 y to the power n minus 1, that is also n minus 1 derivative of y, and so on. a2 y double dash plus a1 y dash plus a naught into y instants coefficients. So here if we don't have a constant coefficient, in case if we have functions of x here like a n of x into y n plus a n minus 1 of y n, so this is a kind of a more generalized kind of equations, linear differential equations of higher order. So what method we use? We use the method variation of parameters. So what is this method? Method of solution is, if for example we consider this, we restrict this higher order equation into second order differential equation, and that is a2 of x y double dash plus a1 of x into y dash plus a naught of x into y equals to g of x. If we have this kind of equation, first step is that you have to convert it into the standard form. And what is the standard form? You already know. The standard form is by dividing the leading coefficient with the equation that makes it into the standard form. Like if you have the leading coefficient here with the highest derivative, that is a2, if we divide it with the equation, then a1 divided by a2 is the quotient of two functions, variable functions, is also a function, and also a naught of x divided by a2 of x is also a new function, and g of x divided by a2 of x is also a new function, so that is also a scalar function. So I convert it into the standard form and I represent it in the standard form. Plus, instead of a1 divided by a2, I write it as p of x into y dash plus a naught divided by a2. Instead of writing it, I am using q of x into y equals to, this is not a g of x no anymore, it is r of x. So this is the standard form of second order differential equation. Solution for this homogeneous second order differential equation is, you know, if it is a second order, then we say that yc is c1 into y1 plus c2 into y1. And one more thing is, c1 and c2 are constants here, and y1 and y2 are linearly independent functions. We already know, we have studied in this in the method of reduction of order. So y1 and y2 are linearly independent functions. So now we come to the point. Variation of parameter, what it does, we just, by looking at the complementary functions, we just suppose it on the basis of this complementary function. Particular solution is just assumed with this by looking at this complementary function. This is so simple. Let yp is, our assumption is, let yp is equal to, instead of c1 constant, because here we don't have any more constants, we have here functions a2 of x, a1 of x, a naught of x. These are some kind of functions of x. So instead of constants, because y1 and y2 are solutions, linearly independent solutions or functions. So it remains as it is, y1 plus y2. I'll write it as it is like this. So but instead of c1 you just have to replace u1 of x, and instead of c2 you just have to replace u2 of x. So this is all, and you have to move on with this particular solution, because u1 is also a function and y1 is also a function of x, and u2 is also a function and y2 is also a function of x. So you have to do the you have to apply the product rule here. So I am just writing u1 and u2 instead of u1 of x. So it becomes u1 dash plus y1 into u1 into y1 dash plus u2 dash into y2 dash plus u2 into y2 dash. So this is the product rule, and from that you just select one thing. It is a main point of this complete method, and that is you have to select first term and this third term. This is the first term and this is the third term. So what you have to do, you need to do is you have to select this common these first and third terms. So our second step, first step is this step, first step is standard step, second is this assumption based on the complementary solution, and third step is you have to select this and this equals to 0. So choose u1 dash into y1 plus u2 dash into y2 equals to 0. So this is our main assumption. I will tell you the wisdom behind of this selection later on. Okay, this is done. So the remaining if this combination of these two terms is equal to 0, then yp dash is left with second and third term, and that is u1 into y1 dash and u2 into y2 dash. So this is left here, and then we are taking the second derivative of this first derivative, and that is yp double dash. You have to keep in mind the standard form. It is written in your registers or any notes. So by looking at this you can also apply it. So by applying this product rule here in the first term, it becomes u1 dash y1 double dash plus u1 into y1 double dash, and also in the second term it becomes this term, you have to use the product rule, so that becomes u2 dash into y2 dash plus u2 into y2 double dash. Okay, that's also fine. Now what you have to do, you have to apply this yp double dash and yp dash and this yp simple u1 into y1 plus u2 into y2 in the standard form of equation. So by looking at the standard form of equation, I am applying here. First is yp double dash. Yp double dash is u1 dash into y1 dash plus u1 into y1 double dash plus u2 dash into y2 dash plus u2 into y2 double dash. So that is yp double dash in the standard form, plus p of x into yp dash. Yp dash is u1 y1 dash plus u2 y2 dash plus q of x into yp. Simple yp is u1 into y1 plus u2 into y2 equals to r of x. Now just look at the homogeneous part. The homogeneous part is u1. So this is only the term of u1. It doesn't have derivative of u1. It's only u1, and this is also the term. You have to multiply it with this u1, and then this. You have to select this u1 terms and write it in the combination. Is that you have to take it common. So by taking it common, that becomes u1 into y1 y2 double dash plus p of x y1 dash plus q of x y1. Okay, and in the second step you have to select only u2 terms, that is u2 y2 double dash, u2 y2 dash, and u2 y2 simple u2. There I will tell you why we are selecting these terms. So u2 is y2 double dash plus p of x y2 dash plus q of x y2. This is simple. Now you will write the remaining terms. Remaining terms are plus u1 y1 dash plus u2 y2 u2 dash y2 dash, and no term is left, equals to r of x. Now because y1 is a linearly independent solution, that means its left hand side y1, sorry, this is y1 double dash, not it's y1 double dash. I think I have written, there is a mistake here, so you have to correct it, y1. So y1 dash, this is because y1 is a linearly independent solution, so it obeys the standard form of equation, and for the homogeneous part this left hand side is equal to 0. So this side is equal to 0, right? And also y2 is another linearly independent solution, so that means it obeys also the standard form of second order linear differential equation, homogeneous differential equation. Because it is a solution, so that means it is also equal to 0. So that means that these two, u1 and common term and u2 and common term is equal to 0. So now your equation reduces to u1 dash y1 dash plus u2 dash y2 dash equals to r of x, and you name it as equation 2, and by your selection you name it as equation 1. So these are two equations. You are left with only system of two equations, and that is u1 dash plus y1 and u2 dash y2 equals to 0, and u1 dash y1 dash and u2 dash y2 dash equals to r of x. So these are two equations, and you can see that you can write it in the matrix form, and in the matrix form if I write it, I have seen that your unknowns are u1 dash and u2 dash, and rest it becomes your coefficient matrix, that is y1 and y2 and y1 dash and y2 dash into unknowns are u1 dash and u2 dash equals to your constant vector becomes not a constant vector here, but right hand side vector becomes this. Okay, now you have two unknowns, u1 dash and u2 dash, so you have to find it u1 dash and u2 dash and then integrate it. Simple rule is this: you can use any method, simultaneous equations or echelon form or reduced echelon form, you can use any kind of, but I am using here the Cramer's rule, that for finding out the first variable is u1 dash, you have to replace this right hand side vector instead of first column, and for finding out the second unknown, here is second unknown u2 dash, you have to find out the you have to replace this right hand side vector instead of second column divided by its determinant, because Cramer's rule is all about the determinants. So first is and one more thing is that a determinant of this vector is y1 and y2, and y1 dash and y2 dash. You can see that this is the formula of Wronskian, so you can also write it as w. Okay, u1 dash is equal to determinant of this first column divided by determinant of this whole matrix A. I can say this is a matrix A, this is X, and this is B. So this is that becomes system of linear equations, but here it is like the derivatives involved in this, so that you can say is Wronskian. Okay, so determinant of this, So if I replace this first column, it becomes 0 r of x and y2 into y2 dash, okay, divided by y1 into y2, y1 dash into y2 dash. So that becomes determinant. So determinant of 2 cross 2 is a into d minus b into c. So a into d is 0, so that becomes minus y2 dash into r of x divided by, you can say it a Wronskian, you can also say it y1 into y2 dash minus y2 into y1 dash. So if you integrate it, you will get u1, simple. And instead of, in case of u2, what you need to do, if you can see this, if instead of u2 you just replace it with the second column, so that becomes y1 and y1 dash remains same, and 0 and r of x. You just have to replace this instead of second column divided by this Wronskian y1, y2, y1 dash and y2 dash. So what you will be left, if you cross multiplied, a into d is non-zero and this b into c is 0, so it will be a positive quantity, and that is y1 into r of x, simple, and divided by this, again same Wronskian. And if you u2 dash, and if you integrate, this is also left with the variable x variables. So if you integrate it, then you will get the solution u1 and u2, and then you replace it in this solution, yp equals to u1 into y1 plus u2 into y2. So this is the method of variation of parameters.